What if the universe has a cause, and the cause existed before time? Not before the Big Bang in any ordinary sense, before time itself, before the concept of before had any meaning at all. What if the thing that produced everything, every particle, every law of physics, every second that has ever passed, existed in a state that our language is structurally incapable of describing? That is not a theological question. That is the question sitting at the center of modern cosmology, and almost nobody is asking it directly. Here is what we know. The universe had a beginning. 13.787 billion years ago, everything that exists came into existence from a state of unimaginable density. Space expanded. Time began. The laws of physics switched on. Every serious model of cosmology agrees on this basic picture, and the observational evidence behind it is overwhelming. The cosmic microwave background, the large-scale structure of galaxies, the ratios of light elements in the oldest stars, all of it points back to the same starting point. The Big Bang is not a guess. It is one of the most confirmed events in the history of science, and every model we have built to describe it runs into the same wall. You push the equations backward, you get closer and closer to the first moment, and then the physics breaks. Not approximately breaks, completely breaks. The numbers go to infinity. The framework produces nonsense. The theory predicts its own failure at the exact moment you need it most. That is the singularity. And it is not a gap that better instruments will fill. It is a structural problem. The mathematics stops working, which means causality stops working, which means the most basic question you can ask, what caused this, has no answer inside the framework we are using to ask it. Here is my position on that. This is not science being careful. This is science running into a genuine boundary and not always saying so clearly enough. The honest statement is this: we do not know what produced the Big Bang. We do not know what, if anything, existed before it. We do not know whether the word existed even applies to whatever was there. And we have built extraordinary models trying to answer that question. Quantum tunneling, eternal inflation, cyclic brains, holographic time. And every single one of them agrees on one thing. The universe, as we experience it, is not the whole story. Something was underneath it. Something that operated outside of time, because time was not yet a thing. Not a force in any familiar sense. Not a location. Not an event. Something for which we have no word, because every word we have was made inside time and depends on time to function. Cause and effect require a before and an after. Before and after require time. If time did not exist, causality did not exist. Which means whatever produced the universe did not cause it, in the way a match causes a fire. The rules were different, or there were no rules. Or the rules were the thing being created. Physicists working at this boundary, Stephen Hawking, James Hartle, Alexander Vilenkin, Roger Penrose, are not mystics. They are not speculating loosely. They have built rigorous, peer-reviewed mathematical frameworks that attempt to describe what happens at and before the Planck time, 10 circumflex 43 seconds after the bang, the point at which general relativity fails, and quantum mechanics takes over, and even quantum mechanics begins to strain. These frameworks are not the same. They disagree on the specific mechanism, but they converge on the same structural fact. The universe did not simply emerge from nothing in the empty sense of nothing. It emerged from a state that is prior to time, prior to space, prior to the existence of any physical law. That convergence is what this is about. Not mythology, not metaphysics in the dismissive sense. The actual published science, from the researchers closest to the problem, pointing at the same uncomfortable possibility from completely independent directions. Something existed before the universe. We cannot see it. We cannot name it properly. We may never be able to confirm it by direct observation. And the physicists who have spent their careers closest to that boundary are not embarrassed to say they do not know what is on the other side of it. 13.787 billion years ago, everything that exists exploded into existence from a point smaller than anything you can meaningfully imagine. Not small like a grain of sand. Not small like an atom. A point with no meaningful size at all, containing all the matter, all the energy, all the space, that would eventually become everything you have ever seen or touched or measured. That is the Big Bang model. And it is not speculation. It is the most tested, most confirmed, most observationally supported framework in the history of science. The evidence points to it from a dozen independent directions: the expansion of galaxies, the abundance of light elements, the temperature of the universe. Every measurement agrees. The model works. And then you push it to the very beginning, and it breaks. Here is what breaks. At the first moment, not 1 second in, not 1 millisecond in, but at the actual origin point, the equations produce values that cannot describe physical reality. Temperature goes to infinity. Density goes to infinity. The curvature of space goes to infinity. Infinity is not a measurement. Infinity is what a calculation produces when it has stopped describing something real. Physicists have a name for this. They call it a singularity. And what that word actually means, in plain terms, is that the theory has reached a point where it predicts its own failure. The math stops working. The framework that correctly describes everything from the formation of galaxies to the behavior of light has a hole in it at the very moment it is most needed. That is not a gap waiting for a better telescope. That is a structural problem in the architecture of the theory itself. It is worth being precise about what a singularity is not. It is not a very dense object sitting in space. It is not a ball of extremely compressed matter. It is not something physical that you could, in principle, examine with better instruments. A singularity is what happens when the numbers in the equations become undefined. Divide by zero. The output is not a number. It is a signal that the equation has been asked to describe something it was not built to describe. The Big Bang singularity is exactly that signal. The theory points at the first moment, and the mathematics says nothing here makes sense. Not in a mysterious way. In a technical, formal mathematical way. The prediction is nonsense, and that matters. Before you can understand why that is a problem, you need to understand one thing about Einstein. In 1915, general relativity changed what time and space actually are. Before Einstein, time was the backdrop, the stage on which the universe performed. Fixed, absolute, ticking along regardless of what was happening in it. Newton assumed this. Everyone before Einstein assumed this. Einstein showed it was wrong. Space and time are not a fixed stage. They are woven into the fabric of the universe itself. They bend, they curve, they are shaped by matter and energy, and they are defined only within the universe. They do not exist separately from it, which means without the universe, there is no time. No time at all. Not slow time, not stopped time. No time as a concept. Think about what that means for the question everyone wants to ask. What happened before the Big Bang? The question sounds reasonable. It is grammatically correct. It has the same structure as asking what happened before the storm, or before the war, or before you walked into this room. But those questions all assume time was already running. Before the Big Bang, by the best framework we have, time did not exist. Asking what happened before it is like asking what is south of the South Pole. You can say the words, the sentence passes, and it points at nothing. There is no south of the South Pole, because the geometry of a sphere makes the concept meaningless at that location. There is no before the Big Bang, because the geometry of space-time makes the concept meaningless at that boundary. Here is my position on that. The fact that the question is grammatically broken does not mean the thing it is pointing at does not exist. Something produced the Big Bang. The universe did not write itself into existence. Whatever that something was, it operated in a state where time as we understand it had not yet come into being. That is not the same as nothing. It is something for which we do not yet have a name or a complete framework. And the question of what that something is drives everything that follows in this story. Now look at what the observations actually show. The cosmic microwave background is the oldest light in the universe. It is not old the way a mountain is old. It is radiation left over from roughly 380,000 years after the bang, when the universe had cooled enough for atoms to form and light to travel freely for the first time. Before that point, the universe was opaque, plasma so dense that light could not move through it. Every photon scattered immediately. The record simply does not exist. Not because we have not found it, because the physics of that era made it impossible for information to escape in the form we can now detect. The fossil record of the universe goes back almost to the moment of creation, and the moment of creation itself is sitting behind a wall that no instrument we have built or will ever build can see through. The Big Bang model works. The evidence for it is overwhelming. The expansion of the universe, the cosmic microwave background, the abundance of light elements, all of it consistent, all of it pointing back to a single hot, dense origin point. The model is not in question. What is in question is the first moment itself. Because at the first moment, the model breaks. Not gradually, not in a way that better instruments might eventually resolve. The mathematics produces values that are infinite, undefined, physically meaningless. Temperature becomes infinite. Density becomes infinite. The curvature of space-time becomes infinite. And in physics, when your answer is infinity, that is not a result. That is a signal that the framework you are using has reached the boundary of what it can describe. That boundary has a name. The Planck time, 10 to the negative 43 seconds after the bang. That is not a small number in the ordinary sense. It is the smallest interval of time that has any physical meaning under our current laws. Before it, or rather at it, general relativity stops working. The equations that describe gravity and the large-scale structure of spacetime simply cease to produce meaningful answers. They were not built for conditions that extreme. And here is the problem. The theory that does work at extreme smallness is quantum mechanics. Quantum mechanics handles the subatomic world with extraordinary precision. It is the most tested framework in the history of science. So when general relativity fails at the Planck scale, the natural move is to reach for quantum mechanics instead. Except quantum mechanics and general relativity are not compatible. They give contradictory answers about what is happening at that scale, not slightly different answers, fundamentally incompatible ones. The two best theories humans have ever produced cannot both be applied to the same moment. One of them is incomplete, possibly both are incomplete, and neither one can describe the moment the universe came into existence. This is not a minor technical disagreement, waiting for a clever paper to resolve it. This is the central unsolved problem in theoretical physics. Quantum gravity, the framework that would unify these two theories and describe the universe at the Planck scale, does not exist. Physicists have been working toward it for decades. String theory is an attempt. Loop quantum gravity is an attempt. Neither has been confirmed experimentally. Without quantum gravity, the moment of creation remains behind a wall that our physics built and our physics cannot cross. Here is my position on what that actually means. Most discussions of the Big Bang treat the singularity as an inconvenience, a technical footnote before the model takes over and starts working. That framing is wrong. The singularity is not a footnote. It is the location of the most important question in all of cosmology. What happened there? What the conditions were, what produced them, whether anything preceded them, is precisely what we cannot answer. And the reason we cannot answer it is not lack of data. It is that the conceptual tools we would need to ask the question correctly do not exist yet. Now take that one step further. Cause and effect. The principle that every event has a prior cause is not a freestanding universal law that exists independently of physics. Causality operates through the laws of physics. Events cause other events because physical processes propagate through time, energy transfers, forces act, and the laws that govern all of that are what make causation possible. At the singularity, those laws break down, which means causality breaks down with them. The question of what caused the universe is a causal question. It assumes that the moment of creation was an event with a prior cause. But if causality itself is not operational at that boundary, then the question contains an assumption that does not hold. You are asking for the cause of an event using a framework that cannot function at the location of that event. This is not a dodge. The physics itself tells you that the structure of the question is wrong. What caused the universe applies a rule. Every effect has a cause, to a moment where that rule has no jurisdiction. Stephen Hawking made this point as precisely as it has ever been made. The universe was not made in time. It was made with time. Time is not the container the universe was placed into. Time is something the universe brought into existence, along with space and matter and energy. Before the Bang, there was no before. Because the concept of before is a temporal concept, and time did not exist yet. That answer resolves a grammatical problem. It does not resolve the deeper one. Because whatever produced the conditions for that making, whatever state preceded the existence of time, if preceded is even a word we are allowed to use, that state had to exist in some sense, in some framework, operating under some set of rules that have nothing to do with the physics we know. The universe was not made in time. It was made with time, and whatever was responsible for that making existed in a state where time did not yet exist as a concept. Stephen Hawking's answer to the before question is one of the most discussed and least understood ideas in modern cosmology. It has been cited in thousands of papers. It has been explained in best-selling books. It has been summarized in documentaries and lectures and interviews going back 40 years. And most of the people who have heard it walk away thinking they understand it when they do not. Because the idea sounds simple. It is not simple. It is one of the most precise and unsettling things ever written down in the history of physics. Here is what Hawking and his collaborator James Hartle actually proposed. Under the extreme conditions near the Big Bang, when the universe was compressed to the smallest scales physics can describe, time does not behave the way it behaves now. At those scales, quantum effects dominate. And in quantum physics, under those conditions, time can behave like a spatial dimension, not metaphorically, mathematically. It rotates, it loses its time-like character, and starts to look, in the equations, like another direction in space. What that means for the structure of the universe's beginning is everything. Think about a globe. Pick any point on that globe and start moving south. You can keep moving south for a long time. Eventually, you reach the South Pole. Now ask yourself, what is south of the South Pole? Nothing. Not because something is blocking you, not because a wall exists at that coordinate, because the geometry of a sphere makes the question incoherent. South is a direction defined by the structure of the surface. At the South Pole, that direction runs out. It does not continue into something else. It simply ends, and the word south stops meaning anything. The no-boundary proposal says the beginning of the universe works the same way. Travel back in time toward the Big Bang, and time is behaving normally. Keep going. Get close enough to the beginning and time starts to change. It rounds off. The time-like direction gradually becomes space-like, and at the very beginning, there is no time direction at all. Just space. A closed, rounded geometry with no edge, no boundary, and no moment before it. Asking what happened before the Big Bang is not a question that points to a hidden answer. It is a question whose terms stop applying at exactly the point where you most want them to work. That is the no-boundary proposal. The universe has no boundary in time. Not because something came before and erased the boundary, because the geometry of the beginning makes the concept of before undefined. Now here is my position on what this actually means. Either this is the most elegant solution to the creation problem ever produced, or it is a very sophisticated way of saying the question cannot be answered. I am not sure those two things are different. The math works. It is internally consistent. It connects general relativity and quantum mechanics at the level of the wave function of the entire universe. Jim Hartle and Hawking were not doing philosophy. They were solving equations. And the equations produced a universe that requires no cause, has no boundary, and in the precise technical sense of the word, began from nothing. That is not a small result. That is the entire problem of creation handled in a single mathematical framework. No prior cause, no external agent, no moment zero sitting on top of some earlier moment. Just a rounded geometry of spacetime that closes on itself at the beginning the way a sphere closes at its poles. The universe did not emerge from something. It emerged from a shape. But here is what the proposal does not do. And this matters. The no-boundary proposal describes the shape of the beginning. It tells you what the geometry looks like. It tells you that the wave function of the universe is consistent with a finite, self-contained spacetime that needs nothing outside itself to exist. What it does not tell you is why that geometry exists at all. Why there is a wave function with those properties, rather than no wave function. Why there is a universe described by that mathematics, rather than nothing described by no mathematics. That question is sitting right underneath the proposal, and the proposal does not reach it. This is not a criticism. It is an honest accounting of what the framework achieves, and where it stops. Hawking was clear about this. The no-boundary condition tells you the universe is self-sufficient. It tells you time has no edge. It does not tell you why there is something capable of being self-sufficient, rather than an absence of everything including self-sufficiency. That gap is not a small one. It is the oldest question in philosophy, and modern cosmology, for all of its precision, arrives at the same place that medieval theologians arrived at when they pushed their own frameworks as far as they could go. You can describe the structure of the beginning with extraordinary mathematical detail. You cannot explain why the structure exists. The description is complete. The explanation is not. What the no-boundary proposal gives us is this: a universe that is its own cause in the only sense that quantum cosmology allows. A closed, self-contained spacetime that did not emerge from a prior state because there was no prior state for it to emerge from. The shape of the universe at its origin is a sphere. There is nothing south of the South Pole. Why there is something rather than nothing? Why there is a universe with that shape rather than no universe at all? The no-boundary proposal does not touch. The quantum mechanical answer to the creation problem is the most unsettling answer in all of physics, and it does not get easier the longer you sit with it. The no-boundary proposal says time rounded off near the beginning. It says the question of what came before is geometrically meaningless. That is elegant. That is satisfying at the level of mathematics. But it leaves something untouched. It describes the shape of the beginning. It does not explain why anything tunneled across that boundary at all. Quantum mechanics steps in at exactly that point. And what it says is stranger than anything the geometry alone implies. Start with something you can test. An electron sitting on one side of an energy barrier should not be able to cross to the other side. Classical physics is unambiguous about this. The electron does not have enough energy. The barrier is real. The math says it stays put, and yet it crosses, not occasionally, not under special conditions, routinely, predictably, with a probability that physicists can calculate to extraordinary precision. The electron does not find a gap, it does not get a push, it simply appears on the other side. This is quantum tunneling. It is not a theoretical curiosity, it is the operating principle behind the transistor. Every processor running right now relies on electrons doing exactly this, billions of times per second, in every device connected to every network on Earth. This is the most tested phenomenon in physics. The experiment runs continuously, in every piece of electronics humanity has built. Here is what that means for the creation question. If particles can cross barriers without cause, if they can appear where they have no classical right to appear, simply because quantum probability permits it, then the principle scales. Not automatically, not without serious theoretical work. But the framework exists. Alexander Vilenkin built it out formally in 1982. His model describes the universe quantum tunneling into existence from a state with no space, no time, no matter, no energy whatsoever. Not from a quantum vacuum. That distinction is critical, and it almost always gets lost. A quantum vacuum is not empty. It has structure, it has fields, it has energy, it has geometry. Vilenkin's starting point is not that. His starting point is the absence of all of those things. Nothing in the strongest sense the word can carry. No prior state, no substrate, no laws waiting to be activated, nothing. And then, because quantum probability is not nothing, because the mathematical structure of quantum mechanics permits transitions that have no classical analog, a universe. This is the part where the intuition breaks, not bends, breaks. Because the feeling that something cannot come from nothing is not just a cultural assumption. It feels like a logical necessity. It feels like the kind of thing that should be immune to empirical revision. Things have causes. Effects follow causes. Causes precede effects. That is not just how physics works. That is the frame inside which physics works. Vilenkin's proposal is not saying we have not found the cause yet. It is saying the cause does not exist, cannot exist. Not because we lack the instruments, because the structure of time itself makes causality impossible to apply at the moment of creation. Think about what causality actually requires. A cause must precede its effect. Precedence requires time. Before the bang, there is no time. There is no prior moment in which a cause could be situated. The question is not just unanswered. It is unanswerable in principle, not through ignorance but through the logical structure of what causality means. You cannot have a cause without a before. There is no before. The universe may be the one object in existence, the only one, for which the concept of a cause is structurally inapplicable. Not missing, inapplicable. This is what quantum cosmologists mean when they say the universe has no cause. They are not being evasive. They are not hiding a gap behind technical language. They are pointing at a real feature of the mathematics. Causality is a property of systems operating inside time. At the boundary where time comes into existence, causality does not apply any more than temperature applies to a single particle. The concept requires a context. The context does not exist at the moment of creation. Now here is my position on the intuition problem. The feeling that something cannot come from nothing is real. It is persistent. It is shared across every culture that has ever existed on this planet. And it is wrong. Not probably wrong. Demonstrably wrong. That is the data. The electron does not ask permission to cross the barrier. It does not wait for a cause. It crosses because quantum probability permits it. The universe did not wait for a cause either. Vilenkin's math says the probability of tunneling from nothing is not zero. A non-zero probability in quantum mechanics is not a curiosity. It is an inevitability, given enough structure for the concept of probability to exist at all. The intuition that creation requires a creator, that effects require causes, that something cannot emerge from nothing. That intuition is built from classical physics. It was formed in a regime where quantum effects average out and disappear. It does not generalize. And quantum mechanics is not telling us the feeling is probably wrong. It is telling us the feeling is demonstrably wrong. Billions of times per second, in every transistor on Earth. In 1980, Alan Guth proposed an idea that solved three of the most embarrassing problems in standard Big Bang cosmology, and, almost as a side effect, raised a question that has been making physicists uncomfortable ever since. The three problems are worth naming. The first is the flatness problem. The universe is geometrically flat to a precision that requires extraordinary fine-tuning at the moment of the bang. Any deviation from exact flatness in the early universe would have compounded over billions of years into something radically different from what we observe. The second is the horizon problem. Regions of the universe that are too far apart to have ever been in contact with each other have identical temperatures. The cosmic microwave background is smooth to 1 part in 100,000 across the entire sky. That should not be possible if those regions never exchanged energy. The third is the magnetic monopole problem. The physics of the early universe predicts the production of exotic particles that we've never been detected. They should be everywhere. They are nowhere. 3 separate anomalies. 1 solution. Inflation says that in the first fraction of a second after the bang, the universe expanded exponentially fast. Not fast in the ordinary sense. Faster than light. A region smaller than a proton expanded to something the size of a grapefruit in roughly 10 to the minus 32 seconds. The driving force was a quantum field, the inflaton field, carrying enormous potential energy. When that field decayed, the energy converted into matter and radiation, and the expansion rate dropped to the slower rate we observe today. That is the standard Big Bang cosmology, entered at the moment inflation ended. Everything before that moment is what Guth's proposal was actually about. The flatness problem is solved because exponential expansion flattens any initial curvature the way inflating a balloon smooths out wrinkles. The horizon problem is solved because the entire observable universe grew from a single causally connected region before inflation stretched it apart. The monopoles are diluted to undetectable density because they were produced before the expansion swept them apart. The model works. The observational support is strong. The temperature patterns in the microwave background match the predictions of inflation with precision that other frameworks struggle to replicate. That is not incidental. That is the reason physicists take this framework seriously. Here is where it becomes uncomfortable. The inflaton field does not decay everywhere at once. Quantum mechanics prevents that. The field is subject to quantum fluctuations, and those fluctuations mean that in some regions, the field decays quickly, inflation ends, and energy becomes matter. Those regions become bubbles. Our universe is one such bubble. But in the vast majority of the volume outside any given bubble, the field has not decayed. Inflation continues, and because the expansion rate of the inflating background is faster than the rate at which bubbles can nucleate, the total inflating volume keeps growing. It never shrinks. New bubbles form constantly, each one a separate universe expanding from its own local bang, but the space between them grows faster than they multiply. The inflation field does not wind down. It is eternal. This is not a feature Guth was trying to build into the theory. It follows automatically from the mathematics once you take the quantum nature of the field seriously. André Linde developed the framework further in the early 1980s, and the conclusion is unavoidable. Eternal inflation is not an add-on. It is what quantum field theory says inflation looks like from the outside. The implications for the question this series is asking are direct. If eternal inflation is correct, our Big Bang is not the beginning of everything. It is the beginning of our bubble. The inflation field predates it, not by a measurable interval because the concept of time we use, the time measured by physical processes inside this universe, did not exist before our bang. The inflation field operates on a temporal structure that is entirely external to our own. Asking how long the field existed before our bang is like asking how far north you are when you have left the surface of the globe. The coordinate system does not apply. What you can say is this: the field is older than our time. Whatever it means to exist in a state before our temporal framework was created, the inflation field does that. That is the closest physics currently gets to naming something older than time and pointing at it with a specific physical mechanism. The other bubbles that form in the eternal inflation background are not required to look like our universe. The physical constants, the strength of gravity, the mass of the electron, the cosmological constant, each of these may take different values, in different bubbles, depending on how the inflaton field decays in each region. An effectively infinite number of bubbles, each with different outcomes. Some would collapse immediately. Some would expand forever, but never form structure. Some small fraction might resemble ours. You will never observe any of them directly. The bubbles are separated by inflating space that expands faster than light can cross it. No signal from another bubble has ever reached us. No signal from ours will ever reach another. Each bubble is causally isolated from every other, by construction. Here is my position on the objection that always follows from this. The fact that the other bubbles cannot be directly observed does not make eternal inflation untestable. The theory makes predictions about the statistical properties of our bubble, about the shape of the microwave background fluctuations, about the distribution of large-scale structure. Those predictions can be checked. Some of them have been checked. The framework holds. Dismissing eternal inflation because we cannot see the other universes is like dismissing atomic theory in 1900 because nobody had seen an atom directly. The indirect evidence is real evidence. The mathematical consistency is not decoration. It is the reason the framework survives contact with data. What eternal inflation gives you then is a specific and physically grounded answer to how something could exist before our time. Not a creator, not a cause in the conventional sense, a quantum field that never fully decays, that has no beginning in any framework our physics can construct, and that generates universes as a natural consequence of its own dynamics. The question of what created the inflation field remains open. That is honest. But the field itself is the first concrete candidate in this series of frameworks for the thing older than our time. Not a metaphor. A field. You cannot see the other bubbles, but their existence is a mathematically necessary consequence of a theory that solves problems we can observe directly, and that distinction matters. Before this universe, maybe there was another one. Not a metaphor, not a religious idea dressed in scientific language, a formal cosmological possibility with rigorous mathematical structure behind it, one that physicists have been developing seriously for decades. The intuition is ancient. Hindu cosmology described cycles of creation and destruction stretching back through time, without a beginning. Nietzsche built an entire philosophy around eternal recurrence. The idea keeps returning because it solves a problem that every other framework struggles with. If the universe had a beginning, something caused it. If something caused it, what caused that? The cyclic answer is blunt. There was no beginning. There will be no end. The question of what came before the bang is answered the same way every time. Another bang. The basic structure is simple. The universe expands. Eventually, through one mechanism or another, that expansion ends or transforms. What follows is either a contraction back toward a dense state, or a decay into conditions that are mathematically equivalent to starting over. Then, a new bang. Then expansion again, indefinitely in both directions. No first moment, no last moment. Time is not bounded. It does not start anywhere, and it does not stop anywhere. This is not a small claim. It means every cosmological question that begins with the words "before the universe" has a straightforward answer. Before this universe, there was a previous universe. And before that, another one. The sequence has no flaw. Here is where you have to stop and take the objection seriously, because there is a real one. The second law of thermodynamics states that entropy, the total disorder in a closed system, always increases over time. Always. This is not a tendency or a statistical preference. It is one of the most fundamental constraints in all of physics. An infinite past means infinite time for entropy to accumulate, which means the universe should be in a state of maximum disorder right now. Everything at the same temperature. No stars, no structure, no complexity. Dead. The fact that the universe is ordered and complex and full of structure is, on the face of it, evidence against any model that requires an infinite past. Early cyclic models ran directly into this wall. Every cycle produces more entropy than the last. Trace the cycles backward and they get shorter and shorter. The math still requires a beginning. The problem was not solved. It was repackaged. Roger Penrose took the entropy problem and built a specific solution to it. His conformal cyclic cosmology starts from a different observation. At the end of an eon, after all the stars have burned out and all the black holes have evaporated through Hawking radiation, the universe approaches a state with no massive particles left in it. Only massless particles, photons, gravitons. And massless particles do not experience time in the conventional sense. They do not have clocks. They do not measure duration. The universe in its final state and the universe at its initial hot, dense state share a mathematical property. They are both conformally equivalent. The geometry connects. The end of one eon maps cleanly onto the beginning of the next. Entropy does not accumulate across the boundary in the way that breaks earlier models, because the boundary itself performs a geometric reset. The second law is not violated. The universe at the end of an eon is not the same as the universe at the start of the next one. But the math allows a continuation that does not carry the full entropic weight of the previous cycle forward. This is not hand-waving. The formalism is specific. It makes predictions, including observable predictions about patterns in the cosmic microwave background, that Penrose has spent years trying to verify. Then there is a second model, built from an entirely different direction, that reaches a structurally similar conclusion through completely different machinery. Paul Steinhardt of Princeton and Neil Turok of Cambridge developed the ekpyrotic model in 2001, derived from string theory. In string theory, the fundamental objects of reality are not point particles. They include higher dimensional structures called branes. Our entire observable universe, everything you can see or measure, corresponds to one three-dimensional brane. There is another brane, parallel to ours, separated by a gap in a hidden extra dimension. These two branes move, slowly, over enormous stretches of time. They drift toward each other along the extra dimension. When they collide, the collision releases energy into both brains. That energy is what we experience as the Big Bang. The universe expands, evolves, and eventually the brains drift apart again. Then they drift back. Then another collision, another bang. The cycle repeats. What is older than time in this model is not a previous version of our universe. It is the higher dimensional space in which the brains exist. That space was there before the collision that created our Big Bang. It will be there after the next collision. It has no beginning in any sense we can identify. It does not operate on our temporal structure, because our temporal structure is a product of what happens when two of its components touch. The thing older than time here is not a force. It is not an agent. It does not decide to create universes. Universes are simply what happens when two brains in that higher dimensional space collide. Creation is not an event in this framework. It is a consequence of geometry and motion. And here is my position on what that means. People hear cyclic cosmology and they hear an evasion. Another way of pushing the question back one step. But that is not what is happening in the rigorous versions. Penrose and Steinhardt are not saying the question has no answer. They are saying the answer is structural. The thing older than time is not a cause. It is a substrate. The higher dimensional geometry of the ekpyrotic model does not create universes the way a craftsman makes something. It generates universes the way a surface generates waves. The waves are not caused by the surface in any intentional sense. They are what the surface does when it moves. That distinction matters. It changes the shape of the question entirely. The structure that generates universes in these models is not a god, not a force, not anything with intention. It is a geometric fact about dimensions we cannot see, and universes are what happens when that geometry moves. Roger Penrose has won a Nobel Prize for proving that black holes must exist. That is not a minor credential. Penrose shared the 2020 Nobel in Physics for demonstrating mathematically and rigorously that singularities are not artifacts of idealized models. They are real predictions of general relativity. He proved this alongside Hawking in the 1960s. The theorems they produced together are foundational. They are taught in every serious graduate program in physics on Earth. When Penrose proposes a cosmological model, it is not speculation wearing the costume of science. It is a working mathematician operating at the frontier of the same framework that produced those theorems. That distinction matters enormously for what comes next. His model is called Conformal Cyclic Cosmology. The basic structure follows the cyclic logic from the previous frameworks. The universe expands, evolves, reaches an endpoint. But Penrose's specific mechanism is not a crunch and bounce. It is something more subtle and, in a technical sense, more precise. At the extreme far future of any given eon, all massive particles have either annihilated or decayed. The universe becomes dominated entirely by radiation and massless particles. And here is the key. Massless particles do not experience time. They travel at the speed of light. For a photon, no time passes between emission and absorption. A universe populated entirely by massless particles is, from a physical standpoint, a universe where time has lost its meaning. The geometry of that endpoint, Penrose argues, is mathematically identical to the geometry of a Big Bang. Not similar, identical, under a specific mathematical transformation called a conformal rescaling, n. The end of one eon and the beginning of the next, at the same geometric surface, described by different scales. One cycle's dying moment is the next cycle's creation event. This is the heart of the model. Not a physical collision, not an energy bounce, but a geometric match. The mathematics allows the continuation to be drawn directly. No singularity, no wall, no gap in the record, just a transformation of scale at the boundary. The entropy problem that collapses older cyclic models is resolved because matter itself is gone at the transition point. Disorder cannot accumulate without mass to carry it. The slate is clean by the time the geometry turns over. Now here is where conformal cyclic cosmology separates itself from every other cyclic framework. It makes a specific prediction. A prediction you can test with instruments we actually have. At the end of each aeon, the largest structures in the universe, supermassive black holes, spiral together and merge. Those mergers are among the most energetic events physically possible. They release enormous amounts of energy in gravitational waves and radiation. Eventually those black holes evaporate through Hawking radiation. Those final evaporation events, played out at the extreme end of each aeon, should leave an imprint that survives the conformal transformation into the next cycle. The imprint takes a specific form. Concentric rings of slightly different temperature in the cosmic microwave background. Not random variation. Structured rings, centered on the locations where the largest black hole mergers from the previous eon occurred. If conformal cyclic cosmology is right, those rings are in the CMB right now. Penrose and his collaborator Vahe Gurzadian analyzed CMB data and published papers claiming to have found exactly that: concentric low-variance rings, a pattern that should not be there if the Big Bang is the absolute beginning. Here is my position on the controversy that followed. The response from the cosmological community was not silence. That is important. Unlike some of the questions this series has examined, this one got engagement. Other research groups looked at the same data and reached different conclusions. Several published analyses concluded that the ring patterns Penrose identified are consistent with what you would expect from random fluctuations in a standard Big Bang model. That the pattern is not a signal. It is noise that looks structured because humans are very good at finding patterns even in noise. This is a legitimate scientific objection. It is not dismissal. It is the field doing exactly what it is supposed to do. Other groups have found tentative support for Penrose's patterns using different datasets and different statistical methods. The debate is live. It has not been resolved. Both sides are using the same data and reaching different conclusions, which means the question is genuinely hard, not obviously answered in either direction. What is not in dispute is the logical consistency of the framework itself. No one has demonstrated that conformal cyclic cosmology is mathematically broken. The argument about whether the CMB patterns are real is a statistical argument, not a theoretical refutation. The model stands, the evidence is contested, and consider what the evidence would mean if it is real. The rings in the CMB would not be a product of our universe. They would be a signal from the eon before ours, from black holes that formed, grew for hundreds of billions of years, merged and evaporated in a universe that ended before our Big Bang began. The oldest radiation we can observe, the CMB, is roughly 13.8 billion years old from our perspective. Those rings, if genuine, would be older than that by an amount of time that is not meaningfully expressible in any unit tied to our universe. They would be the last trace of something that finished long before we started, preserved through a mathematical transformation that erases all physical structure except the faint temperature whisper of those final massive events. Every cosmology textbook on Earth describes the Big Bang as the beginning. Chapter 1, page 1. The origin point of everything. Penrose is saying that framing is wrong, not approximately wrong. Structurally wrong. The Big Bang is not a beginning. It is a seam. A transition between eons in a sequence that has no first page. Our universe is not the opening of the story. It is a chapter in a book with no cover. Contested evidence sitting in the oldest light we can observe, pointing to a universe that burned and died before ours was born. There is a version of this problem where the question itself is built on a false assumption. Every framework covered so far takes time as a given. Something existed before time, or time is eternal, or time had no beginning. All of those positions treat time as a real foundational structure, a container that either existed or did not exist. But what if time is not foundational at all? What if time is a derived property? Something that emerges from a deeper level of reality the way other properties emerge, the way heat emerges, the way pressure emerges. That possibility changes the question entirely. Not what was before time, but what is time made of? Here is the analogy that makes this precise. A single molecule of gas has no temperature. Temperature is not a property of one molecule. It is a property that emerges when you have a large collection of molecules moving and colliding. The motion is real. The molecules are real. Temperature is real. But temperature is not fundamental. It is what happens when the fundamental things interact at scale. Remove the collection and temperature does not become zero. It becomes undefined. The question of what temperature a single molecule has is not a question with a very small answer. It is a question that contains a category error. The concept does not apply at that level. Here is my position. The same logic may apply to time itself. And if it does, asking what existed before time is not a question with a difficult answer. It is a question built on a false premise. The premise that time is a foundational structure rather than an emergent one. The framework that formalizes this is the holographic principle. The core result is this. All the information needed to describe a three-dimensional region of space can be encoded on a two-dimensional surface surrounding it. Not approximately. Exactly. This is not a metaphor or an intuition. It is a precise mathematical result derived from string theory, confirmed through the ADS/CFT correspondence, one of the most tested and cited relationships in theoretical physics, with thousands of independent verifications since Juan Maldacena published it in 1997. The implication is radical. The three-dimensional world you experience may not be the fundamental level of reality. It may be a projection. The information is on the surface. The volume is what the surface generates. Apply this to cosmology, and you get the Hartle-Hawking holographic picture. Think of the early universe as a disk. On the outer edge of the disk, you have the universe as it exists today. Matter, space, time. The full structure of physical reality as we experience it. As you move inward toward the center of the disk, you move backward toward the origin. Time becomes less defined. The further in you go, the less time-like time becomes. At the center, the origin point, time has no meaning at all. There is no before, no after, no sequence. What exists at the center is information, a quantum state, a set of encoded relationships that contains, in potential, everything the universe will become. It is not nothing. Nothing would be the absence of that state. This is a state with properties, with structure, with information content. But none of those properties are temporal. There is no clock at the center of the disk. There is no clock because the clock has not emerged yet. This is the most direct answer currently available in theoretical physics to the question of what is older than time. Not a prior universe, not an eternal inflation field, not a colliding brain. A timeless quantum information state, a state from which time itself holographically projects outward, the way the three-dimensional image on a hologram projects from a two-dimensional surface. Time does not begin at the origin in this picture. Time grows out of the origin. The difference between those two statements is not semantic. Growing out of something and beginning at something are structurally different. One requires an edge, a moment when time switches on. The other does not. Time in the holographic picture has no first moment. It has a limit, a place where the projection becomes too faint to read. The center of the disk is that limit. Now here is where intellectual honesty requires a pause. The holographic principle itself, the ADS/CFT result, the mathematical relationship between a volume and its bounding surface, is established physics. It is not speculation. It is as well confirmed as anything in theoretical physics gets without direct experimental test. The extension of that principle to cosmological origins, to the Hartle-Hawking disk picture, to the claim that time is emergent from a timeless quantum state, that is extrapolation. That is physicists taking a confirmed mathematical structure and asking what it implies at scales and conditions we cannot observe directly. It may be right, the logic is sound, and the math is consistent, but it has not been confirmed, and you should know that when you evaluate it. What it offers is not a proven answer. It is the most mathematically rigorous framework currently available for asking the question in a way that does not break down immediately. What it does change is the shape of the question. If time is emergent, then the thing older than time is not older in a temporal sense. It is deeper. It exists at a level of description where time has not yet appeared as a concept. It is the substrate, the information layer, the quantum state from which the dimension of time holographically grows. That is not nothing. That is also not something you can point to, or measure, or observe from inside the projection it generated. Time does not emerge from nothing in this framework. It emerges from something that contains no time. And those are not the same thing. Here is the problem that runs underneath all of it. Every framework covered so far, no boundary, quantum tunneling, eternal inflation, holographic emergence, arrives at the same wall. Not a wall of missing data, a wall built into the tools we are using to think. Every concept we reach for when we try to describe what existed before time is a concept that was built inside time. Cause and effect, before and after, something acting on something else. These are not neutral descriptions, they are time-dependent structures. And we are trying to apply them to a question that exists, by definition, outside of time. This is not a problem physics can solve with better instruments. It is a problem with the shape of human thought. Augustine identified it in the 4th century, not as theology, as logic. When people asked him what God was doing before the creation of the world, his answer was precise. Time itself was part of the creation. There was no before. The question assumes a temporal state prior to time, and that assumption is incoherent. He was not evading the question. He was identifying a structural error in how the question was formed. That is the same answer Stephen Hawking gave 1500 years later using a completely different set of tools. The universe was not made in time, it was made with time. Augustine and Hawking were not agreeing on theology, they were agreeing on the geometry of the problem. Medieval philosophy and quantum cosmology approached the same wall from different directions, and put their hands on exactly the same surface. Here is what that means for the language we use. Every grammatically normal sentence in English has three parts: a subject, a verb, an object. Something does something to something else. When you say something created the universe, you have imported three assumptions in one sentence. There is an agent that exists. That agent performed an action. That action had an effect. But actions require time. An action is a change of state from moment A to moment B. If the creating agent existed in a state where time did not yet exist, then the word acted does not describe what happened. There is no word that does. The sentence "something created the universe" is not false. It is grammatically broken in a way that looks grammatically valid. The verb has no temporal home. Try it with causality. Something caused the Big Bang. Causality is a relationship between events. Event A precedes event B. Event A is the reason event B occurred. Causality requires a sequence. Sequence requires time. At the boundary of the Big Bang, time does not exist yet, which means causality does not exist yet, which means the word caused is describing a relationship that cannot operate at the moment you are trying to apply it. Every normal sentence we use to frame this question smuggles temporal assumptions in through the grammar. We may not be able to ask the question correctly, not because we lack information, but because the language we have was built for a universe that already exists, and we are using it to reach past the point where the universe begins. Mathematics gets further than words here. That is not a coincidence. The wave function of the universe, as Hartle and Hawking formulated it, is a mathematical object. It assigns probabilities to configurations of space and geometry. It does not have a narrative. It does not have a before. It does not include a variable for what produced it, because the framework that would make that variable meaningful does not apply to it. When physicists say the no-boundary proposal describes a universe with no cause, they do not mean the cause is unknown. They mean the mathematical object that describes the beginning of the universe has no slot in it for the concept of cause. The question what created the wave function is like asking what is north of the North Pole. The geometry of the object makes the question undefined. Mathematics can represent that. English cannot. And that gap between what the math can hold and what a sentence can carry is where most public confusion about these ideas lives. What would it mean to have an answer we cannot express? Not an answer we have not found yet. An answer that exists, in the sense that the mathematics is consistent and complete, but that cannot be translated into subject-verb-object form without immediately becoming false. This is not an abstract concern. Physicists working at this boundary encounter it directly. They write the equations. The equations are coherent. Then someone asks them to explain what it means in plain terms, and the plain terms fail. Not because the physicists are poor communicators, because the thing the equations are describing does not have a plain terms version. There is no analogy that preserves the actual content. Here is my position on that. This is not a failure of physics. It is physics being honest about the limits of the instruments it is using. Language is an instrument. It evolved to describe events in a world where time exists. Using it to describe the origin of time is like using a thermometer to measure weight. The instrument is not broken. It was built for a different job. The physicists who are closest to this problem are not stuck or embarrassed. They are precise. They will tell you exactly what the equations say. They will tell you exactly where the equations stop applying. They will tell you exactly where the language fails. That precision is what the frontier actually looks like, not mystery dressed up as profundity. A specific boundary, mapped in detail, with an honest account of what is on this side of it, and what cannot be seen on the other. And what is on the other side, if there is one, is not describable as a cause. It is not describable as a force, or an agent, or a thing that acted. The further in you go, the less it looks like anything that initiated a sequence. It looks more like the condition under which sequences became possible, not the thing that started time. The further in you go, the less something older than time looks like a creator, and the more it looks like the material that time itself is made from. And here is my position on why that happens. The asymmetry of professional risk is the same here as it was with the Silurian hypothesis. Ask the uncomfortable questions seriously and get it wrong and your professional standing suffers enduring harm. Stay inside the technical boundaries of your subfield. Produce rigorous work on safely bounded problems and nothing happens to you personally. The incentive structure does not reward the most important questions. It rewards the most answerable ones. Those are not the same thing. Here is the honest inventory. The universe is 13.787 billion years old. It began in an extraordinarily hot, dense state. Space and time did not exist before the Big Bang. They were created at the bang, which means asking what happened before It is not a question the universe is built to answer in any conventional sense. The laws of physics as we currently understand them stop functioning at the Planck time, roughly 10 to the negative 43 seconds after the bang. That is not a measurement limitation. That is the framework itself failing. Before that threshold, general relativity and quantum mechanics give contradictory answers, and we have no theory that reconciles them. This is not a gap that more funding will close quickly. It is the central unsolved problem in theoretical physics. That is what we know with confidence. Now here is what we have built. 5 major mathematical frameworks exist for describing the state before or beyond the Big Bang. The Hawking-Hartle no-boundary proposal describes a universe with no temporal edge. Time becomes spatial near the beginning, the way latitude becomes undefined at the South Pole. There is no first moment, there is no boundary. The question of what came before dissolves into the geometry. Alexander Vilenkin's tunneling model describes a universe that emerged by quantum tunneling from a state with no space, no time, and no matter, not from a quantum vacuum, which still has properties. From nothing in the hardest possible technical sense. Then there is eternal inflation, an unending quantum field that spawns bubble universes continuously, our Big Bang being one local event in a structure that has no beginning in any direction we can point. Then brane cosmology, derived from string theory, in which our bang was a collision between 2 membranes moving through a higher dimensional space, a space that predates our universe entirely. And Penrose's conformal cyclic cosmology, in which aeons connect to each other through a mathematical transformation at the boundary between the finite future of one universe and the Big Bang of the next, an unbroken chain of cycles with no first link. Each of these frameworks is internally consistent. Each has been peer-reviewed and published in legitimate scientific journals. Each makes predictions, some of them testable in principle, some already tested at the margins. None of them has been confirmed by direct observational evidence. None of them can be, given the instruments we have or are likely to have within any reasonable research timeline. Here is my position on what that means. The fact that 5 rigorous peer-reviewed frameworks exist without a way to choose between them is not a sign that physicists are guessing. It is a sign that the question sits at an observational boundary that the structure of space-time itself enforces. You cannot see behind the bang the same way you cannot see behind a horizon. Not because something is blocking you, but because the geometry makes the territory inaccessible. These models are not mythology dressed in equations. They are the honest products of the best mathematical tools humanity has ever built, applied to a question that those tools can approach but not fully resolve. Now look at what we genuinely cannot know. We do not know what, if anything, existed before time. We do not even know whether existed is the right word. That word implies a state persisting through time. And if there was no time, the word may not apply. We do not know whether causality functions at the moment of creation. Causality is a property of systems operating inside time. At the moment time itself comes into existence, there is no prior moment available for a cause to occupy. We do not know whether the question why is there something rather than nothing has a physics answer at all, or whether it is a question that sits structurally outside what any physical framework can address. That is not defeatism, that is precision. There is a difference between a question we have not answered and a question that the architecture of our universe prevents us from answering. The honest state of the evidence is this: multiple sophisticated models, no observational way to distinguish between them, real mathematical constraints on what is possible, and a boundary at the Planck scale where every framework we have hits a wall simultaneously. That wall is not new. Physicists have known about it for decades. What has changed is how clearly the frontier researchers will say, on the record, that the wall is real, not a temporary obstacle, not a problem that the next generation of colliders will solve. A structural feature of what it means to ask about origins inside a universe that was itself created. The cosmic microwave background takes us back to 380,000 years after the bang. Before that, the universe was opaque to light. The bang itself is behind a curtain that photons cannot cross in the direction we need. Gravitational wave astronomy may someday push that boundary back further, to the first seconds, maybe earlier, not to before. The thing we are trying to see is behind a wall that the laws of physics built, and no version of a bigger telescope changes that. Here is what every single framework in this story agrees on, regardless of the specific mechanism, not on the details, not on the mechanism, not on whether the substrate is a quantum field, or a higher dimensional geometry, or a timeless information state with no spatial character at all. On the structural conclusion, the universe as we experience it is not the bottom of the stack. Something is underneath it, and every rigorous mathematical framework physicists have built to describe the origin of everything arrives at that same wall, from a different direction, and stops at the same place. That is not a coincidence. That is a signal. Here is my position on what that signal means. When 5 independent frameworks, no boundary, quantum tunneling, eternal inflation, cyclic cosmology, holographic emergence, all agree that the universe requires a substrate that time itself cannot contain, the honest response is not to say the question is too hard. The honest response is to say the question has a shape. We cannot see the answer directly. We can see what the answer has to look like. And what it has to look like is something that does not exist inside time, does not operate by the rules of cause and effect as we experience them, and does not leave a directly observable trace in the physics of our universe. Not because it is hidden, because the wall between our time and whatever is behind it was built into the structure of creation itself. The specific mechanism is where the models disagree. Hawking and Hartle say time rounded off near the beginning the way the surface of a sphere rounds off at the South Pole. There is no before, not because something is blocking you, but because the geometry of the beginning makes the concept undefined. Vilenkin says the universe tunneled into existence from a state with no space, no time, no matter, no properties at all, not from a quantum vacuum, from nothing in the strictest technical sense. Guth's eternal inflation field says our bang was a local event in a structure that never began and will never end. Steinhardt and Turok say 2 brains in a higher dimensional space collided, and that collision is what we call the Big Bang. And the higher dimensional space those brains move through predates every bang that has ever occurred. Penrose says the mathematical geometry of a dying universe connects continuously to the initial conditions of a new one, and the thing that persists across that boundary is not matter, not energy, not time, but conformal structure, pure geometry, different mechanisms, same conclusion. We are not at the origin. The origin is behind a wall, and the wall is made of physics. Now here is where it becomes a human problem, and not just a technical one. Every civilization that has existed on this planet has had a creation story. Every single one. Mesopotamian, Egyptian, Hindu, Greek, Norse, Aztec, Aboriginal Australian. The details are different. The structure is the same. Something existed outside of time, something that did not require a cause, something that the rules governing everything else did not govern, and that something produced the universe. For most of human history, the framework for that answer was theology. The names were different. The structural conclusion was not. Augustine in the 5th century said time was created with the universe, that God exists in a state where the concept of before does not apply, that asking what God was doing before, create. Tyon is asking a broken question. He arrived at this through philosophy and scripture. Hawking arrived at it through differential geometry and quantum field theory. The God Augustine described and the no-boundary quantum state Hawking described are not the same thing. But they are answers to the same question, and they have the same shape. That is worth sitting with. Not because it proves anything theological, it does not. But because when the oldest philosophical tradition on the planet and the most mathematically rigorous physical framework of the modern era both point at the same structural feature, the question of what that feature is becomes harder to dismiss. Here is what I think the convergence is telling us. Not that we have found the answer. We have not. Not that the question will eventually yield to better instruments. It will not. The wall is not an instrumental limit. It is a geometric one. What the convergence is telling us is that the question has a real answer, not a symbolic answer, not a metaphorical answer, a real one. There is something that is older than time. We know roughly what properties it must have. It must exist outside the temporal structure of our universe. It must not require a cause in the sense we understand causality. It must be capable of producing a universe with the specific properties ours has. And it must leave no directly recoverable trace in the physics of the universe it produced. What produced it, if anything, the framework does not reach. That question remains entirely open, and may always remain open. What we have is the shape of the answer, the shadow, not the object. Every model gives us a different description of the shadow. They disagree on whether it is a quantum state, a geometric structure, an eternal field, a previous eon's dying geometry. They agree that the shadow is there. They agree that it is cast from something that does not exist inside our time. And they agree uniformly that the shadow is the largest thing we will ever be able to observe, because the shadow is the entire physical universe. That is the honest answer from the frontier. Not that we are close, not that the next instrument will close the gap. The honest answer is that the question is real. The answer has a shape, And the shape of the answer is something that every independent framework in physics, built by different people, using different mathematics, addressing different observational puzzles, has converged on from different directions. Something older than time produced everything. We have not found it. We have found the shadow it cast when it made everything else. And the shadow is the size of the universe.